1.50 gram sample of hydrocarbon undergoes complete combustion to produce 4.40 grams of carbon dioxide and 2.70 grams of water. What is the empirical formula of this compound? So we all know that a hydrocarbon contains only C and H atoms, and that's to say carbon and hydrogen atoms. So since we don't know the moles of carbon and hydrogen in this hydrocarbon, we will write carbon X and hydrogen Y. So we have our hydrocarbon, then hydrogen Y. They undergo a combustion, and that means they react with oxygen to produce carbon dioxide plus water. They react with oxygen to produce carbon dioxide plus water. So step 1, we have to separate carbon and hydrogen from carbon dioxide and water. So if we go with carbon first, we have 4.40 grams of CO2. So in 1 mole of CO2 we have 44.01 grams of carbon dioxide, and in 1 mole of carbon dioxide we have 1 mole of carbon. So in 1 mole of carbon we have 12.01 grams of carbon. So we have to calculate that first. .40 times 12.01 divided by 44.01, and that gives us 1.20. So we have to separate hydrogen from water. We have 2.70 grams of water, H2O, times in 1 mole of water we have 18.01 grams of water. So in 1 mole of water we have 1 mole of we have 2 moles of hydrogen. In 1 mole of hydrogen contains 1.0078. So we have to calculate that. 2.70 times 2 times 1.0078 divided by 18.01, and that gives us 0.30. So step 3 is to divide these numbers with the atomic mass of carbon and hydrogen. So for carbon we had 1.0.20, and we had, for hydrogen we had 0.30. So we have to divide them with their respective atomic mass. So the atomic mass of carbon is 12.0, and the atomic mass of hydrogen is 1.0079. So if we divide 1.20 divided by 12.0, we get 0.1 for carbon, and if we divide 0.30 divided by 1.0078 or 79, whatever you like, we get the same number. So step 3 is to divide these numbers with the smallest one among them to find the whole ratio. So that means we will use 0.1 since it's the smallest. So we will divide them by 0.1, and here's 0.1. So 0.1, this will give us 1 for carbon, and this will give us 3. So the ratio of the elements present in the hydrocarbon will be 1:3. So that means our empirical formula of this compound is carbon 1 and H3. So this is our answer.